first let's talk about a little bit about logistics. There were, despite Discord not being used, there were some regular hands up questions in the last one. So I just want to go over the final exam just to make sure everybody's on the same page of what's going on with that. So it's next Wednesday. This is section B. So you'll be in Hofstadter 114 at 7:15 p.m. for the final exam. I don't know how I feel about these late exams, but it is what it is. We'll have a late exam ending at 10:15 if you need the whole time. The toughest part about the late exams is I always like to grade right after the exam and get grades done. So me and the TAs all get together and grade right after the exam. We proctor the exam and then grade it right away. So we'll be up to like midnight, 1 o'clock, maybe 2 in the morning grading the exams, but you will get your results that night. I like final exam grades being out as fast as possible, because once final exam grades are out, that means I can get final grades out, and that means I can start my break. So I get that grading out pretty quick. And the TAs like it because I get them pizza and all that. But anyway, getting sidetracked. Next Wednesday is the final exam. So the final exam is your chance to make up any of the first round quiz application objectives that you didn't earn throughout the semester. So that's LO1, LO2, LO3, the application objectives on those learning objective quizzes. I got to rename things. I think next semester I'm going to rename everything so it's not overloading the term objective. But those 3 learning objectives had application objectives on the quizzes. Anyway, if you got the AO on all 3 of those quizzes, there's no reason for you to show up to the final exam. I got nothing for you. Nothing to offer. For the final exam, you can just take the day off. Also, if you have 8 application objectives earned through other means, through either you got some of the lab quizzes but not all 3 of the AOs, you got the AOs on the projects, you got the lecture questions, you got the expected deadlines, and you got enough AOs that you have 8, you already got an A, you don't need any more. Again, no reason for you to be at the final. If you want to show up, if you don't need to take the final and you show up just for practice or for whatever, I'm not going to stop you. That's great. I assume you have better things to do on finals week, like other finals to study for and get ready for. So I would expect you to just not be there. If you're in any other case, that means you didn't get all 3 of the AOs on the lab quizzes, and you can come to the final exam to make them up, and you don't have an A already, and you're coming to the final exam to improve your grade. And I guess if you're on one of those cutoff areas where maybe you missed one of those, but you're already, I didn't even think of this situation in the previous lecture, but there are situations where there's also no point to come to the final. You know, you can make your decisions depending on what position you're in. But if you have 6 application objectives and you only missed one of the AOs on the quizzes, again, there's no reason for you to show up. You can get up to 7, but that doesn't get you up to an A. It doesn't change your grade. There's no reason for you to be there. You're not going to hurt my feelings if you don't show up to the final. But if you're in any other situation, when you come to the final, there will be 3 effectively quizzes. It's going to look like the 3 quizzes that you took throughout the semester, just different versions, of course. And there's going to be 3 of those, one for each of the learning objectives. Whatever ones you've already earned the AO for, you don't have to take. So if you already earned the AO for quiz 1, for example, but you missed it on quiz 2 and quiz 3, you'll only do the parts for quiz 2 and quiz 3. And each of the 3 are graded independently of each other, and they are pass-fail just like the AOs on the quizzes. So if you don't even take the quiz 1, that doesn't affect you at all if you already earned it, whatever. And then quiz 2 will grade pass-fail, quiz 3 will grade pass-fail, whether you get the AO or not. So you can get up 0, 1, or 2 AOs if that's your exact situation. And I think that's all of the logistics. Any questions on anything about the final exam or anything about the course at this point? Yeah. Yeah, you should know coming into the final exam which one you have to take. My plan, so last semester we actually printed out individual exams and had it printed out what you exactly need, and then we had assigned seating. And I don't intend to set it up like that because it was kind of a logistical nightmare. Everybody's reading the seating chart and trying to figure out where the hell they're going. So my thought is just to print out each of the 3, have a pile of each of the 3 quizzes, and then just hand out who needs quiz 1, hand out quiz 1, who needs quiz 2, hand out quiz 2, and do it that way. Or potentially have you mob the front of the room and grab what you need, but I don't really like that plan. But either way, at any rate, you should you should know what you need coming in, so you know which ones to grab. Unless, the only way I'll do assigned seating and printed out exams with your UBID on it and everything, the only way I'll do that is one of the TAs wants to do it, which they did last semester, that's why I did it. But if they volunteer again, then maybe it'll be like that, but otherwise it'll just be stacks of quizzes and I'll hand them out. I like the low-tech solutions. All right, any other questions on this? Yeah. What was that? How many recovery opportunities can be used up to? Or when can you not use recovery opportunities? Next Wednesday. So, I got to process deadlines. You know, I was doing that this morning and then I got sidetracked. I'll do it tonight. But for the programming tasks on the homework, you can use your recovery opportunities, I guess, up until today. If you miss today's deadline, you get an extension until next Wednesday, and then that's it. Because after that, we're getting into final grades are due and finals week and all that. For the quizzes and interviews, you can use as many recovery opportunities as you have. And that's on me to work out the logistics and the scheduling to make sure that you have ample opportunity to take it. So if you have all 4 recovery opportunities left and you're struggling on LO3 quiz, like I'm going to give you 4 more chances to take that quiz, even if some of them, multiple quizzes happen in the same day, for example. Like, I'll figure something out for you. But for tests where recovery opportunities are, you get more time, like we're running out of time. So it depends what you're using your recovery opportunity for. That's my short answer. Anything else? Yeah. How many questions are going to be on the final? Good question. So they'll look just like the quizzes, except me and the TAs agree that LO2 quiz had a few too many questions on it. I believe we had 5. That one's going to get trimmed down a little bit. 5 was just a bit much, especially when it's like constructor stack frame, super constructor stack frame. That also inherits something, super constructor stack frame. Just got to be a bit much. Without, a good quiz should test each concept roughly once, sometimes twice just to be sure. But when we're testing the same concept like 18 times by creating objects of types that extend other types, like we don't have to do it that many times. Roughly. Don't be surprised if one of them has 4, but I don't plan on going down to 2 for any of them. Oh, we won't go up to 5 again. That was just a bit much. Other than that, it's just going to look like another version of each quiz. There won't be any big surprises. I shouldn't say that because one of you is going to be like, I wasn't expecting that. Why'd you throw that at us? But there won't be any big surprises on the format of the questions. The questions themselves, I mean, you might feel like you got surprised. I'd say that's not super likely, but just to cover my ass on that one, just in case you do feel surprised. Any question testing the content and the concepts is fair game. Anything else? These are good questions. Okay. Oh, yeah. It's automatic. So if you need a recovery opportunity for task 3 of project 3, I'll send you an email tonight. Of course, I intended to send it out this morning, so if it's tomorrow morning, try not to get too mad at me. But I process all that manually. So I'll process the deadline extensions in Autolab and then send everybody who used the recovery opportunity an email. But you don't have to take any action. I'll do all that on my end. All recovery opportunity usages are automatic. Since your alternative is failing the class, I'm assuming you'll want to use your recovery opportunity. So same goes for interviews and quizzes. If for whatever reason you don't make it this week in lab, if you don't pass both the interview and quiz, the recovery opportunity usage is automatic. And I'll reach out to you for those ones. For any of you who've had a round 3 before, you've had it with TAs for LO3, for what it's worth, this might not even apply to any of you, but for what it's worth, LO3, the round 3 interviews are going to be directly to me, so I'll be handling everything during finals week, because the TA's got other stuff to do. They got final exams themselves to prepare for, final projects to wrap up and all that. Yeah, anything else? Yeah. Oh, what about it? The LO2 quiz or interview? The interview will be with me. The quiz might be with a TA, but we're talking about how to do that logistically. We might roll the quizzes right into the final exam. So as you're taking your shot for the AO, we'll also grade your LO as well during that. So the quiz makeup, you would just take the quiz again, and we would schedule a time for you to do that. We're thinking of, just to make it easier logistically for everyone, just doing that during the final exam. So you take the LO2 on the final exam to try to get the AO. We would also grade your LO on that.
Okay, so it counts twice then?
Possibly. Just don't be surprised if that's what we come up with, because that's my favorite option right now. Otherwise, we got to try to schedule something before the exam. So either Monday or Tuesday, and we were even talking about Saturday, which I didn't like that idea. Even coming in Saturday to take the quiz. I think the easiest thing to do is just roll it in with the final. And then if you don't get it on the final, I'll reach out to you, and Thursday or Friday we'll do something. That'll be a regular interview scheduled with me. I'll reach out to you within the next few days, at the latest, absolute latest, next week, Monday. I don't want to get them out that late, though, because I want to get these things scheduled.
Thank you.
Yep. And as long as you have recovery opportunities left, you could do both of those again, even. And we'll do that late next week. Yeah, anything else? Great questions. Okay, let's get into it. Lecture B. So, what won in the Piazza voting, the review topics, whatever I called it, review topic voting suggestions. What won by a lot was classes in Python, so let's do classes in Python. I'll start with a refresher of Python just to get us in the spirit of Python programming. I'll start with Hello World, and just in like 5 minutes I'll go through modules 1 and 2 from 115, and then switch over to project 2. So my plan is to go through as much of, here's my email. Oh, sorry, I'm supposed to freak out when my email's shown. We'll go through project 2 as much as we can. In the previous lecture, we got through all of task 1, and then Friday, I think we'll just continue this and go through as much as we can get through on Friday as well. So task 1 is what we got through in the previous lecture. I think that's reasonable to get through that again in this lecture, and then which will cover classes and objects and things like that. And then on Friday, we'll go into task 2, which gets our inheritance and polymorphism. So we'll talk about those concepts on Friday. So let's get into it. So just a refresher for Python. Print. Hello, Python. The first thing we saw this semester was Hello, Scala. Python, remember how easy it was back then. This is why we like Python in 115 in a CS1 course. It's just print and then whatever string you want to print. Super easy. You don't have this object, creating a main method. I was going to say imports, but there's no imports. The package statement, we don't have any of that here. We just print the damn thing. We run it, and it prints. And it prints immediately. How fast that is. Do you miss Python with that? I run it, and it runs. That's it. This is the difference between a compiled and one of the differences between a compiled and interpreted language. With Scala, I always step on that thing. With Scala, every time you run anything, you got this progress bar on the bottom. It's got to go across it's got to fill up. That's the compiler reading your code and translating it into another language, Java bytecode, and then running the Java bytecode as an interpreted language. With Python, it's just like, now let's skip all that and just run your code. That's it. It runs your code, period. So as developers is one of the big practical differences between compiled and interpreted languages. The disadvantages, of course, the compiler does a lot of optimization for us. So typically compiled languages are going to be a lot faster because the compiler can rearrange our code when it translates it to make it as optimal as it can, given what compilers are capable of doing. And also the compiler does a lot of checks for us. We get compiler errors. You got compiler errors this semester as opposed to runtime errors. If I have an error in my Python code, the IDE is going to help me out and highlight that for me, but I can still run this code. Like, we don't actually get the error until we hit that line of code. So the first line 1 executes, line 2 tries to execute, but the interpreter gets stuck and says, whoa, X, I don't have a variable named X on the stack. It panics and crashes. But we're allowed to just run with errors, which can usually be a bad thing, especially when the error isn't picked up by the IDE. The IDE can't figure it out, but you have an error like that. That's a bit trickier and very frustrating, but the compiler is going to figure that out. Okay, let's do data structures. My list in Python, we can mix types. Oh my goodness, I forgot what E is. And we could even nest our data structures. We took this for granted in Python, and then we got to Scala, and Scala's like, nah, we're strongly typed here. You need a specific type for that list. Python's like, nah, whatever. Hell, we can even reassign my list to a number. Like, that variable doesn't have, why does it give me a warning for that? Oh, yeah, it's just saying, that's dumb, why are you doing that? If I add a print statement here, it'll be fine. The warning was, why are you doing that? That's the dumbest thing I've ever seen. Your code sucks. Like, thanks, ID. By the way, I forgot the very first step here. So what I'm using here is PyCharm. This is a different IDE. It's not IntelliJ, but it's made by the same people. It has the same interface. Everything's as similar as it can be. I like this suite of IDEs. PyCharm is just like IntelliJ. It's made by JetBrains. They're both made by JetBrains. You can see I also have WebStorm here. But PyCharm, it's set up for Python. IntelliJ is set up for Java or JVM compiled languages that compile down to the JVM. So we have that Scala plugin that makes it really work well for Scala, but it is initially set up for Java. But Java and Scala both compile down to Java bytecode. So we got that plugin, and then it works just great. PyCharm, set up for Python. WebStorm, set up for web stuff. And there's all kinds of other ones. Ruby, RubyMine, Golang. They got IDEs for like any language you're concerned about. CLion for C, if you're interested in using an IDE next semester in 220. PyCharm does have a community and I always forget the name. I remembered it during last lecture and I already forgot. The community and enterprise, community and ultimate editions. Just like IntelliJ, so with your EDU license, your educational license, you can get the ultimate version for free, or you can just stick with the free community version of it. So if you're doing Python development in your future, which you almost certainly will be, at the very least for one of your classes in the future, using PyCharm, strongly recommended. If you're an IDE person, some of you won't be, especially when you get through 220, Ethan's going to try to sell you on just text editors instead of IDEs. Don't let them fool you. IDEs are the way to go. All right. Why would I not use these features if I had them available? But we have our list for element in my list. Print lm. And we can navigate over a list. So we got data structures, we got loops, if, we got conditionals. And remember, white space matters in Python. All this indentation is very critical. If I have an extra space here, everything breaks. So if lm greater than 1.0, Print LM. You know, I was wondering if I'd get away with that one. I didn't. No. Okay. Just so I don't get an error, I'll do this, but this code is pretty somewhat meaningless. I believe this comparison will be alphabetical order, so there will be some meaning to that. If we change this to a 4, I think some of these won't be printed twice. Yeah. So it's comparing it lexicographically for those of you who are concerned. So if it starts with an ASCII value that has a character that has an ASCII value less than the ASCII value of the character 4, then it's not going to print it. Like if I do D, it won't print 3 twice. Okay, so that's data structures, loops, conditionals, variables, print statements, pretty much everything in modules 1 and 2 in 115. So that's just our refresher of Python, get us thinking in a Python way of life again. So let's get to it with homework 2. We have an items, plural, package, and I'm skipping the store package since I'm not going to have a GUI. Actually, I didn't have a GUI in the other one either. But I'm not going to have a separate package for that. I'm just going to have model and tests. And in items, I'm just doing new Python file. I'm going to call this item. So we're on task 1. We need an item class in the model.items package. It's going to have a constructor that takes a string for the description and a double for the base price. We're going to have methods description and price and set base price. So that's what we want to build in our item class. Let's just hop to it. And here's where we get to the good stuff. Classes in Python. This is what we want to get to. So class starts out just like Scala and pretty much every other language with the keyword class. That's going to say I'm about to define a new class. I'm going to call it item. And here's where we get our first difference. In Scala, right here, we would put our parameter list. Not the case in Python. In Python, we're going right to a colon and going to an indented block of code to define this class. And this is where, in a lot of languages, we would start putting our state variables right here. We don't want to do this either. I'll circle back around to this one and explain what this actually does, but don't fall into this trap. This is not how you want to declare your state variables. You'll see that people first learning Python for the first time, including myself, I did that, made that mistake. We'll do that a lot because that's the way Java does it. So if you're coming from Java to Python like I did, that's where you're going to want to put your state variables. No, you don't put them there. So where do you put them, you ask? And where do we put our constructor parameters? We're going to put it in a special method named __init__. Python is filled with this underscore syntax. You'll see it a lot as you get deeper into Python. But init is going to be our constructor method. And you'll see that my IDE, PyCharm, automatically filled in a parameter named self. So self in Python is the same as this in Scala. Let me fill in the rest of this before we get too far. Description, just to make it clear. So this is going to define our constructor, and this is where I can put my constructor parameters. Description and price. And that's going to define our constructor. Self is the same as this. In Scala, this is just a magical keyword that comes from nowhere. Stores a reference to the object that's being created when a constructor is called, and a reference to the calling object when a method and when any other method is called. And it just comes out of nowhere. But in our memory diagrams, we know we create a stack frame for a constructor. We know to put this and a reference to the object being created, and then the two constructor parameters, description and price in this example. Python says, let's not make that so magical and mysterious. Let's explicitly put it as a constructor parameter. It is a constructor parameter. It's just not controlled by the user. But it is added there. It's in the stack frame as a constructor parameter. Let's just make that explicit and avoid a lot of the confusion. So Python just says, no, put that there explicitly. And then the constructor parameters do not automatically become state variables. That's pretty much Scala specific. I'm sure there are other languages out there that do that. Most languages, at least that I've worked with, do not do that. Most languages make you explicitly declare your state variables. Python included. So I'm going to create my state variables by doing self dot variable name, just like this dot some variable name. Self dot some variable name, and that's going to declare a state variable, in this case named the description. I'm going to set it equal to the description constructor parameter. So we have an explicit line that creates a state variable, gives it a name, and then sets it equal to a value from the constructor parameters. Same with, and I'm going to not reuse the names here, just to make it absolutely clear. I can get away with this as long as I understand my scoping rules and which description is going to be used where. But I'll get into trouble later when I have a method name description. When I say this dot description, is it the method or is it the state variable? There's going to be confusion there, and Python will actually grab the method instead of the state variable. So I'll get in a jam later, like I did in the previous lecture because I forgot about that. So base price equals price. And this creates two state variables, the description and base price, and sets them equal to whatever I want them equal to. So that's a constructor in Python. Let's get our methods out here too. Description. We use the keyword return now. If we don't use the keyword return, we don't return anything. That's just like a method that returns unit. So I do want to return something here, and I'm going to return the description, price, return self.price. And I want to be careful here because I was not careful enough. Base price. So it assumed that I meant the method price, which I don't. And then def set. Now in Java, the world of Java, including Scala, the naming convention is camel case. We've been using camel case all semester. You would do set base price. Oh, it hurts my eyes. Python, we don't do that. For whatever reason, different communities come up with different conventions. I'll follow the convention of the language I'm using, and to the point where that that looks bad to me in Python. We use underscores in Python for what it's worth. The new price, self dot base price equals price. I don't know how those things come about in different communities, but it used to bother me a bit more, but now I just know when I switch to Python, this is how I type code. It's weird how I've been able to adjust that over the years. And here's our item class. So that defines the class, and notice that each method also explicitly takes self as a parameter, where this was just magical, it appeared out of nowhere, it just existed, and like, why does it exist? Python makes it explicit. It's because it's a parameter. Let's not hide it. So let's create a test. I won't go too deep into the testing. Don't worry about that. I'm not going to spend too much time over here. But I have a few points I want to make. Specifically, how do we create an object of this type, of this item type, is a big thing that I want to talk about. Task 1. And the other thing I want to talk about is how to create a main method, which I believe is something you don't do in 1.15 these days. I know you didn't the last time I taught it. I don't think you do that still. So we're in an IDE, so it's really easy to create a main method. You just type the word main and let the IDE do it for you. But I want to explain what's actually happening here. First, let's since I used this a few times, let me explain this first. This pass is probably my favorite feature in a language. It just means do nothing. So in Python, you can't have an empty block of code. So whenever I'm setting up my code and I'm not ready to write it yet, like I'm going to put some code in here, but I'm not ready to do that yet. I want to do some other setup, and I want to explain things right now without seeing errors in my ID. So I'll just put pass there as a placeholder, just so I don't have an empty block of code, but I don't actually want it to do anything. Yeah.
Is it similar to null?
No, it's similar to NoOp, if you've used that before, if you had a language with that. It just means don't do anything at all. Like it's telling the interpreter, don't do anything. This is just an empty block of code. Like literally don't do anything. Like I can't say x equals pass. I could say x equals null. No, I can't. Because it's capital. I swear Python has a null, but I forget the syntax of it. But none is effectively null in Python. But I want pass, which means I don't have any code to run here. So a few things here. First, this underscore syntax. You see this a lot in Python. We saw it with init. We're seeing it with name. We're seeing it with main right now. So in 1.15, I believe anyway, you would just write Python scripts. Every Python file is a Python script. You can run the file, and then it just runs all the code in that file. That's the first thing that we did in our main method today. I just wrote a Python script. I run this thing, and it runs all the code. That's not always what we want. And sometimes we just want a little more control over that. So this is going to say, if you're actually running this file, run this code. So whenever a file is executed, it's going to have a name. And if that name is main, it means that that's the file that is being ran. That's the file that's being executed. So if that name is main, run this code. And just like we did, I believe on Friday, I'm not going to put any code in there. I call that a main method usually, but you can see it's not actually a method. But I'm going to defer to a separate method so I don't have a bunch of code in here. Because the only way to run this code in here is to actually run this file. So if I have any code in there that I want to run without having to run that file, or I want to run multiple times, I can't do that. But if I defer to a method and put all my code over here, then I'm going to be good to go on that. I won't get in a jam. So the difference is between running a method and not running a method, or running a file, because why would you ever not run a file? In 1.15, the answer was, well, it's not really a difference. In 1.16, the programs get bigger, and you've seen all throughout the semester, we have multiple files. We have programs with multiple files. They're importing each other. They're using each other. And whenever you import a file, which we're about to do, we're going to import model.items.item. And when you import a file, that file is executed, but it's not ran with a name of main. So if you import a separate file and there's code in that if name equals main, that code is not executed when you import it. It's only executed when you run that file. So a common thing to do would be to put a main down here and have a little bit of testing or whatever down here, and not worrying about that code being executed when you import item from a different file. So that's the big difference. That's why we do main like this. It's when we're both running a file and importing it in different places at different points in time. And then this isn't going to get me what I want. This is going to import the entire module defined by the item file, or that script, which it will execute all this code, but all the code does is define a class, so I'm good with that. I'm not putting code outside of my classes and my functions, because all that code is going to be ran whenever you import the thing, usually something that you don't want to happen. But this is going to import the entire file. What I actually want to do is from this file, import the item class. So from that file, import the item class. And now we can finally start testing our code. Item 1 equals item, I forgot what I used in the the other lecture too. What should we sell? My mind is completely broken. I'm looking at my phone, so let's sell a phone. And phones are way too expensive these days. Let's say we're buying a phone for $1,000. And to create an item to call the constructor, we just straight up call the constructor without the keyword new. We don't use the keyword new in Python. Just call the constructor. The constructor is named the name of the class. Give it the parameters. We don't explicitly pass self. Self will be created and used on the back end by Python, by the interpreter, but we don't have to call self. We don't have to put self anything here. It's only when you're defining the methods, not when you're calling the methods. And then we can import a unit testing library, like we use Scala tests, and if we were using Python in 1.16, that's what we would do. We would import a library and everything. Since we're just doing a quick and dirty example, I'm going to use the assert keyword, which is actually really handy. I'm going to assert, this is a built-in Python thing, assert item1 dot description equals phone, assert math dot, I can type right, item1 dot base price minus 1,000 less than 1/10 of a penny. We're dealing with items, we're dealing with prices, so I'm fine with 1/10 of a penny off. Import math. Let's duplicate this. Item1 dot set base price. Let's get this on sale to something more reasonable, what I'd want to pay for a phone. Make sure that changed. And then we're ready to run this thing. And nothing happens. That's great. So if a test fails, when we're using this assert, if a test fails, it'll cause an error, it'll crash the program, and it'll give us some information about the failing test. If nothing happened when I run this, that means all of my tests are passing, and we're feeling good about our lives and what's going on. But since I'm not using a formal unit testing library, I don't get any green bars or check marks or anything. It's just going to not do anything. If an assert passes, we just go on to the next line of code. So we're still doing automated testing. We don't have to manually parse through a whole bunch of output and figure out what everything's saying and if everything's right. The assert is still automating our testing, but in a more quick and dirty way without as much functionality, not as many features. In fabs, if you're wondering, this is floating point ABS. Since I have a floating point value, I have to call fabs instead of ABS. And yeah, so the big thing is calling a constructor. We're ready for self-checkout, but first, we want a class self-checkout. I'll give you time to take a look at that. Let me just do some setup while you're reading that, and then I can answer any questions. Init, no constructor parameters. Let's just do pass. So we are in need of some TAs for next semester. Usually hiring is only at the end of the spring semester. So this is a little bit different. We have to do an abbreviated, just a quick hiring process to get more TAs for next semester. If you are interested, those of you who are still showing up, you see obviously a lot of empty seats. Those are probably mostly the people I don't want as TAs, if I can be blunt about it. If you're still showing up, you're still interested, you're still listening to the content, you came here for classes in Python, even though you're not being tested on it, probably going to make a good TA, right? At least a better chance than the empty seats. So go to this link. This is going to be gone by the end of lecture. Once lecture ends, I'm removing this link because word will spread and then, you know, what happens. But So go to that link and fill out the form immediately. The form just asks for your U-bit, and then it's going to give you a link to another form. And that's the actual application form, and that form will be open at least till Friday. I'll give you several days to actually apply. But by the end of lecture, this link is going to be gone. That form is going to be closed, and you won't be able to get the other link. So make sure you at least fill this out to get the application form before the end of lecture. I can't stress that enough. Before the end of lecture. It's the end of lecture, shut off. In 10 minutes, it's going to be gone. Yeah? That link doesn't work. Oh, no. It did work for you? Okay. Okay. Maybe that's the first test. You have to get the link to work. You have to type it in properly. There was a good question about this in the other lecture. I'm trying to remember what it was. Oh, somebody asked what the GPA requirement is. I don't have GPA requirements for TAs. If anybody has that same question that they had in the other lecture. Some of my best TAs had actually pretty abysmal GPAs, pretty abysmal grades. I know no one here asked, but in the other lecture they did, so maybe this is of relevance. Maybe you'll find this interesting. But a TA who struggled in 116, a student who struggled in 116 can sometimes make a better TA than somebody who didn't struggle, because you understand what students who are struggling are going through, and having those office hour interactions when somebody's like, man, I'm just really not getting polymorphism, and you can say, man, I've been there. Let me explain how I got through this when I didn't understand it. Can be a much more positive interaction than the student who just steamrolled over 116 and had no difficulties at all. It might be hard for them to get in the mindset of not understanding polymorphism. I've had TAs, some bad TAs in the past who were 4.0s who would just get frustrated in office hours, like, why don't you understand this stuff? It's so easy. Like, that's not a great TA. So that's why I don't have GPA requirements or grade requirements in the class. Yeah.
For the official transcript.
The application I'll leave open for a few days. This form to get the application link is going to be closed by the end of this lecture. So you have a little bit of time to figure out your unofficial transcript and all that stuff and answer the questions, give thoughtful answers to those. But not a ton of time, because so in the spring we usually ask for a resume as well. I didn't ask for a resume this time, so you should be able to apply pretty quick. But I'll give you a few days for that. I just don't want an open, like in the spring, at the end of spring, it'll be an open invite for everybody to apply. And we get over 100 applicants every time. And I'm not looking for a ton of TAs right now. I just got to fill, I have an emergency shortage right now. I got quite a few TAs graduating this semester. Usually you graduate in the spring, but for whatever reason, I have a bunch of TAs graduating in a fall semester. So I'm in a little bit of a jam. I got to hire y'all, which is to your benefit if you want to be a TA. Yeah. You should, if you go to, I forget how, the hub or something, but there's some way to get your unofficial transcript, even if it just has 115 and, what is it? And that should give you a PDF. Just upload that PDF. Yeah. By the end of this Friday, ideally. But I'll probably leave it open a few days later. Like once I start processing them, I'll close down that form. So the sooner the better. I wouldn't wait till the end of next week because it'll be gone by then. By Friday to make sure that you get in. Oops. Any other questions on that? Okay, let's try to quickly get this self-checkout set up so we don't have to do self-checkout stuff next time. I'll try to do this from memory. Number pressed. And if you have questions about that, let me know as I'm typing this. I'm just going to put pass for these right now as I remember what methods there are. clear pressed. I'm going to skip the ones that we don't need for task 1. Def display string. Def items in cart. Pass. I think that's all of them, right? Oh, add item to store. Def add item to store. Pass. Okay, let's just crank these out. So I know I'm going to need some state variables. One, I'll need self dot, I'm going to call items for sale, equals an empty dictionary, self dot displayed string, which I can't name display string because that's the name of a method. Self dot cart equals an empty list. I believe that's it. Number pressed. Number is going to take a parameter number that was pressed. And it's going to be self dot displayed string plus equals the string version of number that was pressed. Enter pressed is going to get an item, scanned item equals self dot items for sale dot get. I got in a jam in this part in the last lecture because I forgot how to do. I thought there was like a get or else method and everything. It's just get and you give it a second argument. Self dot displayed string, and then the second argument will create a new item for error 00. And then if this key doesn't exist in the dictionary, it goes to the default value. It goes to the default value for us. We need to import our item. So from model.items.item import item. Self.cart.append scanned item. Clear pressed self.displayed string equals empty string, self.cart equals empty cart. Display string return self.displayed string. Items in cart return self.cart. Add item to store is going to take a barcode and an item. Barcode and item. And it's going to self.items for sale of barcode equals item. With a minute to spare, we got it. So that's our objective 1, or our task 1. And of course we do testing and stuff. I'm going to skip over the testing. Confident my code works. I forgot to circle back to the thing I said I'd circle back to. So sometimes you want to put a variable here. Do X. And thinking that's going to be a state variable. This will not be a state variable. This is a common mistake that someone new to Python classes is going to make. This is not a state variable. This is going to create what's called a class variable. So in Scala, we would put code and declare variables outside of all the methods, and those would become state variables. No, it's only variables declared inside the constructor, and only variables that are prefaced with self dot. For example, if I do items for sale, I'm going to get an error down here because that's not a state variable, that's a local variable now. I have to do self dot in this case. That says I want a state variable named items for sale. That's the syntax we have to use in Python. Up here, this is going to be a class variable, meaning that there's only one variable named X for the entire self-checkout class. So if I create 10 self-checkout objects, there's only one variable named X, and all those objects share that variable, which is almost always not what you want. So I could do self-checkout.x, for example, and that's going to give me that X. It's part of the class itself. Don't do that unless you actually want that. It's similar to creating an object in Scala and giving state variables to that object. It's almost never what we want because there's only one. It's called the singleton, which is usually a pretty bad state pattern, a pretty bad design pattern to use singletons. All right, but I'm a minute over now, but I wanted to squeeze that in there. So next time we'll talk about polymorphism and inheritance. Have a great day. I'll see you on Friday.